So if you wanted to title this example something other than what I have it titled as, I would encourage you to title it as "Don't see a derivative or of another function? Try it anyway." So sometimes you need to use your substitution to rewrite other parts of the integral. Use substitutions. There's a reason we're going to spend a lot of time on them. They can be tricky, but they're very, very powerful and probably, arguably, the most important foundational rule of integration that you're going to learn. So let's see. I'm going to look at this thing and I say, okay, I've got the integral of x over the square root of x minus 1. And from our advice earlier, say, hey, what's your function? The thing trapped inside of something else. So the x on top is kind of, we'll call it out in the open, he's fine. I look at this and I see x minus 1 is kind of trapped under a square root. So let's just try that. So we're going to go ahead and do that. We're going to try u is equal to x minus 1, and then we're going to relate the differentials. Du dx equals 1. Well, that gives us that du just substitutes directly in for dx. No complicated stuff needed there. So now under this substitution, our integral will become, we didn't touch that x on top, so we'll leave him alone, square root of, there was our substitution, square root of u, and then du. Normally, if this is going to work, this little guy would kind of reduce away. And so I'm looking at it and saying, okay, well, based on our last example, maybe we could try using x instead of x minus 1, the guy on top is our substitution. You could try that, and I encourage you to do it. If you don't see that it won't work, it'll just take a second. But sometimes you get into a trick like this, and sometimes you can actually use your substitution again. So I'm going to do this in blue. We're going to take this information that we already have over here. We're going to say u equals x minus 1. Well, if I wanted to kind of use this fact to get rid of that x, well, I could add 1 to both sides and turn this expression into u plus 1 equals x. And then I could sort of reuse my substitution a second time. And under this substitution, my integral would now become integral of, well, x is now u plus 1 over the square root of u du. And initially, that might not look any better. But we've seen an example where you have more than one thing added together on top, all over the same single denominator term, where we break that up into a couple fractions, and all of a sudden with algebra, it becomes a problem we can do. So let's do that. Our integral is, this integral is now, and blue isn't special here, it's just the pen I'm using. Okay, so looking at that u squared as the square root of u as a common denominator, you have u over the square root of u plus 1 over the square root of u. You kind of undid that addition there. And now tidying up the algebra here, u over u squared is I keep saying u squared, I'm sorry. U over the square root of u is u over u to the 1/2, which becomes u to the 1/2 power. And then the second one is u to the negative 1/2 power for similar logic. And now we've got something we can absolutely do. So u to the 1/2, using our power rule, as we've done a bunch of times here, is 2/3 u to the 3/2 power. Plus u to the 1/2 is negative 1/2 is u to the add 1/2 multiplied by the reciprocal, so 2 over 1 is just 2, plus c. And now we've done it. We've integrated, and now we just need to back substitute so that our answer is in terms of our original variable. So 2/3 times x minus 1 raised to the 3/2 power plus 2 times x minus 1 raised to the 1/2 power plus c. Okay. Yeah. And that was yes. That's the end of this example. That's what I wanted you to see. Is sometimes if you have a tricky problem where you've tried a couple different u's and you don't see it and it isn't working out, sometimes you need to reuse that u substitution to kind of do a second substitution. And then usually what happens is what happens in blue here, that you end up with a problem that you can algebra into an integral that you can do.